Today is 4-4 scientific notation, a new lesson to most of you again. So make sure you have, if you have questions, you take some good notes. Now, scientific notation is a way to write really, really big numbers and sometimes really, really small numbers. So scientific notation for the most part is for very large numbers. Sometimes it's for small numbers also. A lot of times you don't see it. You don't see it too often with small numbers, but it can be used for both, and we're going to talk about both today. So scientific notation is using powers of 10 to express very large numbers and sometimes very small numbers. Standard notation is writing out the whole number, kind of like when we talked about exponential form, we had standard form, and that was writing out the answer. This is the same thing. Standard notation is writing out the whole answer. So first of all, we got to talk about a few different things. I just want to talk about the powers of 10 quick. We kind of looked at this a little bit almost the other day in your assignment. And let's see. If I have 10, what does that look like in a power? It'd be 10 to the first power. Okay. 100 would be 10 to the second power because we know that 10 times 10 gives me 100. And 1,000 would be 10 to the third power because we know that's 10 times 10 times 10. And 10,000 would be 10 to the fourth power. We know that's 10 times 10 times 10 times 10. And then, it can go on 10 to the fifth, 10 to the sixth, 10 to the seventh, 10 to the eighth. Now, many people make the assumption that when it's to the second power, we're going to pretty much, or to the first power, we're going to have 1 0. To the second power, we're going to have 2 zeros. To the third power, we're going to have 3 zeros. Fourth, we're going to have 4. That's not always the case. Most of the time, it's how many times you move your decimal. And people get that confused a lot. Just because you're adding zeros in scientific notation doesn't mean you're going to add zeros. It's how many times you move your decimal. So if I look over here, what this really says is 2 times 10 technically to the third power, and that's maybe how you would see it. So 10 to the third power, 10 times 1,000. Now, like I said before, pretty much the really, really easy way to think about it is however many zeros you have, that's how many times you're going to move your decimal. So 2 to the 1,000 times 1,000 would be 1, 2, 3, 2,000. So 3.4 times 100, moving my decimal 2 times because I have 2 zeros, would be 340. So just getting in your head, that's a really good trick for when you're multiplying by 10, hundreds, thousands, 100,000s is just moving your decimal that many spaces. And you guys know that trick a little bit. We talked about that the other day about moving your decimal. Okay, so what is scientific notation? Here's me writing scientific notation in with a really large number. So technically you can write any number in scientific notation. For the most part, we use, we do this for big numbers, but in this case, we're going to write 234,000 in scientific notation. Now when you write things in scientific notation, you're going to look at the beginning of the number and you're going to find your actual numbers. So numbers that are between 1 and 9. So if I look at 234,000, these are my numbers that are between 1 and 9. That's going to be the first part of my scientific notation. Okay? And then I'm just going to take 234. Oops. And I'm going to write this, so it would have to be how many times I move a decimal to get me 234,000. This number here, this beginning number, always needs to be between let's see, 1 and 10. So to make 234 between 1 and 10, I'm going to put my decimal right here. That makes it 2.34. Now you can just do that. You can just put it in. You just find a way to make those first 3 or 4 or 5 numbers, you're going to make them less than 10. So I couldn't put it here because that gives me 0.234. I couldn't put it here because that's going to give me 23.4. I have to put it between the 2 and the 3 because that gives me 2.34. Now every time I have scientific notation, it's always times 10 to the something power. Well, if I decide to put my decimal between the 2 and the 3, let's say I put it here, my power is going to be how many times I move it out to get to 234,000. So just watch. 1, 2, 3, 4, 5. So my power is going to be 2.34 times 10 to the fifth, because like we said before, it's how many times you move your decimal, not how many times you put in, how many zeros you put on the end. That's not going to always work. So 2.34 times 10 to the fifth, that would be this is 234,000 in scientific notation. And we're going to practice this quite a bit more. So let's do that. let's write this number. Oops. Okay, I'm going to write 874,300 in scientific notation. First step I have to do is I'm going to find my real numbers at the beginning of this number. Okay, I have 8, 7, a 4, and a 3. Where am I going to put my decimal to make this number between 1 and 10? It's going to go right here. Okay, the next step I'm going to do is I'm going to take that times 10, but now I have to figure out what power it's going to be to. So how many times am I going to move my decimal to make it this number? So if I put my decimal here, I move it 1, 2, 3, 4, 5. This would be 8.743 times 10 to the 5th power. Okay, let's try another. Let's do this one. 3,430,000. Yeah, 3,430,000. All right, so the first thing I'm going to do is I'm going to look for my real numbers. There they are. So I have 3, 4, 3. How am I going to make that between 1 and 10? I'm going to put a decimal right here. I'm going to take it times 10. Now that's, let's say we put our decimal here. How many times are we going to move our decimal out to get us 3,430,000? So 1, 2, 3, 4, 5, 6. That would be 3.43 times 10 to the 6th power. Let's try another one. Now you do this one by yourself. Pause me. And you write this in scientific notation by yourself. Okay, so your real numbers. Write me in between 1 and 10. There you go. Times 10. Now it's going to be, if I put my decimal here, it's 1, 2, 3, 4, 5, 6, 7. 10 to the 7th power. Let's do one like this on the side over here. I have 5, 3, 2, 8. And I want to write this in scientific notation. I can do it even though there's no zeros at the end. So here are my real numbers. I'm going to write that like this. Now how many places, if I put my decimal here, how many places am I going to move it to get it out of the number? 1, 2, and 3. That's just like taking 5.328 times 1,000. And if you move it 3 times, that would be your correct answer. So like I said, a lot of times we use this for really big numbers, like things to the 20th power, the things to the 15th power, things that we really, a lot of times that can't handle. Even our calculators a lot of times can't handle these big numbers. So let's do one more. Okay, so my real numbers are here. That 0 has to be included because it's blocked in by my real numbers. Okay, to make this between 1 and 10, it'd be 5.29032 times 10. Now, okay, if I put my decimal here, it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, all right, let's keep going. So now let's write these. They're going to give us scientific notation, and we have to actually write the numbers. Here's the easiest thing to do. This is 4.78 times 10 to the 6th. But if I were you, I would write it like this, and then say, okay, if it's 10 to the 6th, I'm going to move my decimal 6 times. And I would actually do it like this, because otherwise it gets too confusing. 1, 2, 3, 4, 5, 6. And then I'd go back and insert my zeros to where I had my little loop-de-loop things, a space for a 0. Okay, so for the next one, I have 5.677. 5.677. I'm taking 10 to the 3rd. That means I'm moving my decimal 3 times. 1, 2, 3. All right, so here's the next one. Even though my base is a negative number, that doesn't matter. Okay, if it's times 10 to the 4th, I move it 4 times. 1, 2, 3, 4. 17,000, negative 17,000. And the last one here would be 7.56 times 10, times 10 to the 9th. So I'm going to take my decimal and move it 9 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I'd fill in with my zeros. There you go. That's writing it in standard notation. Now let's talk about negative exponents, okay? Negative exponents, super easy. We talked about this yesterday a little bit with our negative exponent or our negative writing negative exponents and positive exponents. But this is really super simple. So a lot of times when we have positive exponents, we're always going to move our decimal this way. Now when we have negative exponents, we're going to move our decimal this way because negative exponents gives me a really small number. Positive exponents gives me a bigger number. Okay, so let me show you this. If this is we're going to write 0.000034 in scientific notation. So it goes the same way, only this time you're going to go to the back of the number and you're going to write that in between 1 and 10. And now, if this is where you had the decimal and you're going to move to the left, 1, 2, 3, 4, 5. This would be times 10 to the negative fifth power. So if you're going to move to the left, you're going to have a negative exponent, and to the right, you're going to have a positive exponent. And if you move to the right, you're going to make a really big number. Move to the left, you're making a really small number. So let's try a few of these. Let's just try this one right here. So I have 0.00000097. So I'm going to take my 9 and my 7 off there, and I'll make that between 1 and 10. I'm going to take it times 10. So if this is where I put my decimal, let's count how many spaces. 1, 2, 3, 4, 5, 6, 7, 8 spaces. So it would be to the negative 8. It does not matter if your number is negative, it matters which way you move your decimal. Okay, so let's do this one. It'd be 8.76 times 10. If this is where my decimal is going to be, 1, 2, be to the negative second. Let's this one down here. Okay, for this one, it'd be 9.86. If I put it'd be to the times 10 to the negative 1. All right, so here's some other ones. We're going to write these in standard notation. It's about the same thing, so let's write 5.2. Now, if it says times 10 to the negative third, you're going to take your decimal and you're going to move it 3 to the left. 1, 2, 3. There you go. There's your number. Same thing here, 9.72, and we're going to take that times 10 to the negative 7, so we're going to move 7 to the left. 1, 2, 3, 4, 5, 6, 7. There's my decimal. I'm going to fill in my zeros. Why don't you go ahead and you do the last two by yourself to make sure you have some good things in your notebook. That's what that should look like. And this was that should look like. Okay, if you have any questions, let me know. Hope you took good notes, and we'll see you tomorrow. Thanks for watching.